Network Dojo.
So we're starting off in section 1 in the blueprint, and the first thing that we're going to talk about is going to be WLAN organizations and standards. And this being the first video in covering this section, let's just take a quick peek at the blueprint first before we dig into the individual details. And if you're not familiar with where the blueprint is, what you want to do is go to learningnetwork.cisco.com. You'll land on a page something like this. On top, we're going to go down to certifications, expert, CCIE Wireless, and you can go to overview, or you can jump right into the individuals. This is kind of the landing page for the CCIE Wireless topics. We see information about the written and lab exam. They both use the same blueprint, so you'll see the same blueprint regardless of which one you choose, but I'll choose the unified exam topics under written. Here we see some details about the written exam. I already talked about those in the introductory video here. But we see the blueprint, and so some of these blueprints, it's one unified blueprint, so they don't have a separate blueprint for lab and written, but they sort of do, because not every section's in the lab, but every section is in the written. And so section number 1, this is what we're talking about here, plan and design WLAN technologies. And if we expand, we see it's 16% of the written exam. And this is more high-level type information. We're not really making anything work here. So talking about WLAN organizations and regulations, standards and protocols, design type stuff would fall underneath here. Generic design, RF planning design, validation. So some of the things that we talk about will very clearly be under here. Some of the things that I talk about, I might talk about them in separate sections of the video series. For instance, when it comes to voice type stuff, I'm probably going to talk about the design of the voice in the voice section. And so while some of these design things, it's a little blurry. Okay, well, when I see this question, is this question in section 1, or is it in the media application section or the AirOS section? Because it has to do with how you configure something on an AirOS controller, but it also has to do with design. I don't know. I'll try to talk about everything. It's just that some of the things that could just arguably be under one or more different sections. So if I don't talk about it here, I hopefully would be talking about it in different sections of the video series. So this section of the video series is going to be a little bit smaller compared to the others. Okay. So let's dig into some of the details that we might want to know here in terms of, again, WLAN organizations and standards. So first up, regulatory bodies, just some organizations that have to do with creating standards and things like that with wireless. So regulatory bodies are created by countries or groups of countries sometimes to define essentially rules for using RF signals in their regions. And so you'll have different regulatory bodies for different areas of the world. Sometimes it's just one country has its own. Sometimes multiple countries sort of share the regulatory body. And then a regulatory domain is a group of countries that have all agreed to use the same RF rules. So the domain kind of defines the actual rules. The bodies are kind of the groups is more the organization that creates the rules. So the regulatory domain is the actual rules that different countries will abide by. And so each country or location essentially says, okay, we're going to use this regulatory domain. And so all the RF stuff in that area needs to follow the rules of that regulatory domain. And that usually has things to do with what channels are allowed, what power levels are allowed, what can you do outdoors versus what can you do indoors, things like that. So when it comes to the written exam, the regulatory bodies that you want to know is basically the FCC, or Federal Communications Commission, which is US, kind of North America. And then we have the European Telecommunications Standards Institute, or ETSI, E-T-S-I. That's basically Europe. And so there's obviously many more, but these are the ones, as far as the exam goes, would be the only two that you really need to be aware of. So first off, FCC, again, it's based in the US. Any US-based stuff is controlled by the FCC. And they create the standards for the -A and -B regulatory domains. And that's used in the United States, as well as some of the surrounding countries here as well. So it used to be just -A. -B is a newer regulatory domain, and we'll talk about the difference between -A and -B because those become important. Whereas ETSI is based in Europe. They use the -E regulatory domain, and that's been pretty static for a longer period of time here. So let's talk about the difference between the dash A and the dash B regulatory domain, because there was a shift, and it wasn't all that long ago that this shift started happening. And so one thing that you want to know is for the different bands, what channels are allowed. It's a good thing to know. So on the 2.4 side, nothing's changed there. Everything's dash A there, and we just have in the, again, dash A regulatory domain, channels 1 through 11. Dash B is a 5 gigahertz only kind of regulatory domain, if I remember right. So channels 1 through 11 is what we have on the 2.4 side, 20 megahertz wide channels, and they have the overlap and all that good stuff. On the 5 gigahertz side, or sorry, the channels are not 20 megahertz wide, they're 5 megahertz wide, which is why we have the overlap in our 20 megahertz channels that, overall utilizations that we use. But there's only 5 megahertz separation between each one. Okay, 5 gigahertz band, that's where the dash A and dash B come into play. That's split into 4 what they call unibands, UNII bands. Can't remember what that stands for, but who cares? We used to be under dash A. Now, as of 2016, we're under dash B. So again, not super long ago at the time of this recording. New APs are leveraging the dash B. So in the lab, you'll actually see a mixture of dash A, dash B, because our 36 or 3700s were dash A's, but our 1800s were dash B's, I believe. Not that we're restricted to only the APs that would show up in the lab, but those are good reference APs to be aware of. So we are starting to have APs that support the dash B regulatory domain. And in that, when we were under dash A, we had 21 channels available to us across those 4 unibands. In dash B, we now have 25 channels usable across those 4 different unibands. And let's actually look at how these are all divvied out here. So I think this was maybe from like a Cisco Live presentation or something like that. But we kind of see the breakdown. So we see channels 36 through 48 in the yellow there. So we see 20 megahertz wide channels, 40, 80, and 160. Let's focus on the 20 megahertz wide channels to begin with here. So Uni 1 is comprised of channels 36, 40, 44, and 48. So 4 channels in the Uni 1 band. In dash A, that was only allowable indoors and that was not usable in the outdoor arena. Moving to dash B, those Uni 1 channels then became usable in outdoor APs. So that's a shift. If you see dash A APs, they very well may not support Uni 1 channels if they are outdoor APs, whereas dash B, they will. Uni 2 is 52, 56, 60, and 64, and there's been no change there. It's usable indoors, usable outdoor, 4 channels in Uni 2. Then there's a jump, so ignore the red. We move to jump to Uni 2, and then we call it Uni 2 Extended. It's not called out as extended here, but Uni 2 Extended would be the ones that start at channel 100. So starting at channel 100 are the Uni 2 Extended, technically a separate Uni band, and that goes 100 up to 144. So the blue ones are the ones that were available under dash A. So 100, 104, 108, 112, 116, 32, 36, and 40. And then the green ones were added as a part of dash B. So that's where our 4 additional channels come in. If we add everything up without the green, anything that's blue or yellow, we would get 21. Once we add yellow, blue, and green together, that becomes 25. So 21 to 25 is our shift, and they all came in the Uni 2 extended range. Now, there's that note at the bottom. Channel 144 was allowed for use prior to the FCC 14-30 order, which is, I think, the dash B, but not actually supported until dash B was introduced. And so I would say as far as the exam is concerned, it was not in dash A, and it is in dash B. So 21 to 25. And then Uni 3 are the only odd number channels are Uni 3 channels. It starts at 149 and goes through 161, or sometimes you see 165 included in Uni 3. But let's do the math. So we have 4 in Uni 1, 4 in Uni 2, so that's 8. 1, 2, 3, 4, 5, 6, 7, 8. In Uni 2 Extended, so 8 plus 8 is 16. 17, 18, 19, 20, 21. So technically 165 should be a part of Uni 3. There's our 21, and then 1, 2, 3, 4 extra to get our 25. That's the 20 megahertz wide channels. Maybe it's worth knowing how many 40, 80, and 160 megahertz wide channels that we have. So let's just count them up real quick, and we'll just focus on dash B at the moment here. So anything in yellow, blue, or green, we count. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 40 megahertz wide channels, which seems reasonable. 25 divided by 2 is 12 and a half, so we just lose one there. So 12 40 megahertz wide channels, 80, 1, 2, 3, 4, 5, 6. 6 80 megahertz wide channels, so we're just cut it in half again. At the 160, you actually only have 2, because we can't cross from 144 to 149, so we can't make that leap. And there's only, what, 12 wide in Uni 2? I think that's right. So we can only get 1 in Uni 2. We can actually combine Uni 1, Uni 2 extended. We can combine Uni 1, Uni 2 together because they actually are adjacent to each other, and that is allowed, so we can get 1 there. So we only have 2 full 160 megahertz wide channels, at least according to this information. I think that would be valid information for the exam. So definitely know your dash A versus dash B, understand the channels involved in each of the bands, know that Uni 2 and Uni 2 extended are technically separate bands, so we have 4 different Uni bands available, and hopefully you should be good for that. I'm going to throw in some miscellaneous stuff too. So CCX, it's not really a regulatory body, but it is, I didn't know where else to put it. So CCX is Cisco compatible extensions. This is something that clients can support. So we would have a CCX capable clients. And depending on the version that they have, it grants them certain abilities. And so the goal of the CCX program, which is a Cisco program, so this is a Cisco thing that Cisco did to sort of create some of these, pre-standard maybe functionalities that clients can adopt, and oftentimes a lot of these things then eventually become standardized in AO2.11, and usually once it's standardized, the CCX stuff may just kind of fall away after that. But the goals of the CCX program, as according to a PDF that I found, is accelerate technology while actively working on standard bodies, enhance end-to-end security, enhance IT administration and end-user experience across mobile device types, and enhance mobility services for reliable business applications. So trying to advance the mobile cause and make things better, essentially easier or better, more advanced type of stuff. And again, usually it's we do this while we're waiting for standardizations to catch up, is oftentimes what happens. So there's 5 different CCX versions, starting from version 1 all the way up to the current version 5, I believe that's the current version. And you can kind of see what things kind of came along with each version here. So at the bottom, version 1, we have long ago, LEAP, WPA, AO2.1x and VLANs per AP, TCAP, Wi-Fi, really old stuff. V2, oftentimes some of the features that we start talking about, V2 is like the entryway. So AP assisted roam, so if you ever configure assisted roaming in your controller, that's a version 2 CCX feature. CCKM came about, which is the fast roaming technology that we had prior to AO2.11r, getting more of a standardized way of doing a similar type of thing. Radio measurements, transmit power control, so some really core stuff. Version 3, WME, so I think that'd be QoS type stuff, proxy ARP, EatFast, WPA2, so enhancing security and performance there. 4, looks like the focus there was on voice, so CAC, power save, UPSD is power saving type stuff, voice metrics, location, things like that. And then version 5 was management frame protection, client reporting, so some of the extra advanced features that came along with that. And so different clients will be compatible at different versions, and the version that they get essentially determines what benefits that they can reap. So obviously a version 3 CCX compatible client can't take advantage of version 4 or version 5 type features. So I guess these are the different versions of CCX. You can kind of see what things came about in the different versions of CCX. As I talk about some of these features in the future, I'll come back and reference, like, you needed this version of CCX for that, but I guess this is sort of a little bit of a master list with that type of a thing. Last thing that we're going to talk about, at least in this particular video, is going to be understanding conversions of dBm to milliwatt. So the dBm, I believe that's decibels compared to milliwatts is the M part of it, compared to and then the milliwatts. So we want to know how to, if I see something in dBm, what's the milliwatts? Or if I see something in milliwatts, what's the dBm? And so the calculations, it's a logarithmic scale is really what it is. So normally, you would use a calculator to tell us, but we have some sort of cheap, easy math that we can use and get us really in a pretty good ballpark, if not the exact number, in the ballpark of the number. And so the reference value that we start with is 0 dBm equals 1 milliwatt. So that's one thing that you have, that's our starting point. 0 dBm is 1 milliwatt. And we just go up from there. We're never going to go down. I don't think we'll ever get into negative dBms here. But when we add, essentially, we have these rules of 3 and rules of 10. Essentially, our two rules that we use to really get us into the ballpark or the exact numbers, just depending. So the idea is that if we add 3 dBm, we double the milliwatts. So in other words, 3 dBm would be 2 milliwatts. So if I add 0 plus 3 is 3. 1 times 2 is 2. Let's say I added another 3. So I went from 3 to 6. I would then multiply 2 times 2 to get 4. So 6 dBm would be 4 milliwatts, and so on up the scale there. So adding of 3 doubles it, and then conversely, if we subtract 3, we have it. And so if I go from 6 is 4, and I drop down to 3, well, I divide it by 2, it gives me down to 2. If I remove 3 again to get me down to 0 dBm, 2 divided by 2 is 1. So add or subtract 3 is a doubling or halving effect. Then the tens. If we add 10 dB, we multiply milliwatts by 10. So if I start at 0 dBm is 1 milliwatt, 10 dBm is 1 times 10, or 10 milliwatts. So 10 dBm, 10 milliwatts. Let's say I add another 10. So from 10 to 20, I then multiply 10 milliwatts times 10 is 100. And so 20 dBm is 100 milliwatts. And then we can go from there. For instance, okay, 20 dBm is 100 milliwatts. What if I subtract 3 dBm? 17 dBm, I cut it in half, right? So I was at 100 milliwatts, I cut it in half, 50. So 17 dBm is 50 milliwatts. What if I get to 10? So again, 10 was 10. And we'll get to this to the next one. So most of the things that we do in the exam can be all figured out by these rules of 3s and rules of 10. So adding and subtracting 3s or 10s, and then doing the math. And while it might not be absolutely spot on perfect, it'll get us close enough, easily close enough to answer the question. So some good reference values to have. 0 dBm is 1 milliwatt, 10 dBm is 10 milliwatts, 20 dBm is 100 milliwatts, and 30 dBm is 1,000 milliwatts, or 1 watt. But oftentimes, try to remember that 20 dBm is 100 milliwatts. And that's a common max power value on our Cisco APs. On the 2.4 side, oftentimes the max power our APs can talk at is 20 dBm, or 100 milliwatts. And so if we start counting down from that, that's where we get to the 17 is 50, 14 is 25. I can get to 17 by getting up to 20, so 0 plus 10 plus 10. So I did 10 times 10 to get to 100. And then I just subtract 3, which halves the milliwatts. And then 14, I just subtract 3 again, halving the milliwatts to 25. How do I get to 13? Well, I go from 0 to 10. So 10 dBm is 10 milliwatts. I add 3, so I double it, gives me 20 milliwatts. And so usually the number is somewhere between 10 and 20 dBm, making the number between 10 and 100 milliwatts. And so, if it's 13, 14, 16, 17, 19, all these numbers are really easy to either start at 20 and count down from 3, or start at 10 and count up by 3. Theoretically, 15, you could just say 0 plus 3 plus 3 plus 3 plus 3 plus 3. So you're doubling it 5 times. So there's different ways to get to different numbers. But like I said, it might not be 100% spot on, especially the plus or minus 3 isn't, I don't know if it's 100% super mega precise, but it's really close. So if you're looking at a question and you're having to say, they say 16 dBm is how many milliwatts? And they're going to give you a bunch of numbers. Well, it's really easy to know 17. 17 is 50. So 16 has to be a little bit less than 50, right? And so if 17 is 50 and 14 is 25, it's going to be closer to 50 than it is to 25. And so all other things aside, let's just split this into threes. And so, okay, there's 25 difference. That's about 8 per interval. So 50 minus 8, about 42. Ballpark. There will be an answer plus or minus 2. And it'll be the only answer that's like in that range. The next one will be like 7 away or something like that. So like I said, you don't have to be like uber precise to really get these calculations out. If you know these plus and minuses, 3s and 10s, you'll get easily close enough to answer any question that they would have in the lab. But be comfortable with this process and being able to translate dBm to milliwatt. It's rare you go the other way, milliwatt to dBm, but you can sort of just reverse the math and try to figure out, okay, well, if I know 17 dBm is 50 and they said it was, 42, so it's probably 16 dBm. So you can get close enough. Another tip is, if you have a lot of these things, especially if maybe it's like a drag and drop, like you have like 4 different dBms over here and 4 different milliwatts over here, and you have to drag and drop, or maybe you have 6 dBms over here and 4 milliwatts, so you're dragging 4 correct ones over here and 2 of them are incorrect ones that don't match up to anything. I mean, set them in order, right? I mean, either the smallest dBm is the smallest milliwatt, or it's one of the smallest milliwatts, right? And so it's going to be a pattern, and so it shouldn't be too hard to figure it out. And we'll leave that here. So we'll definitely talk about a lot of other standardizations, but at least in terms of the regulatory bodies and a few of the standards, hopefully we've covered those appropriately.